Assalamualaikum and a very good day to Miss Azira. My name is Unku Putri Sharina, and today my groupmate and I will be presenting our case study on high-rise building that focus on the post-tensioning transfer floor system. This case study is actually based on my internship experience at PBR Construction Systems, Sindirian Berhad in Shah Alam. During my internship there, I was exposed to many new aspects of civil engineering work, especially the post-tension transfer floor system, which is widely used in high-rise building construction. So, through this presentation, we will explain the function of the post-tensioning transfer floor system, its advantages, its construction method, the design considerations, and the real project implementation based on my internship experience. So, without further ado, let's begin the presentation. Before we go further, I will explain what a high-rise building is. A high-rise building is a structure with many floors, so it has to carry a much heavier load compared to normal buildings. Because of that, it needs a stronger structural system to ensure stability and safety, especially against vertical loads and lateral force like wind. High-rise buildings are commonly used for residential apartment, office, hotels, and mixed-use developments. So for our project and for our case study, we are focusing on the high-rise building that use a post-tension transfer floor system. Let's see what's the meaning of post-tension transfer floor. Let me briefly explain what is the post-tension transfer floor. In a high-rise building, the upper floors often have a different column layout from the lower floor. From the lower floors, it's different between the upper floors and lower floors. So a transfer floor is used to transfer the load safely to the supporting structure below. Compared to a conventional reinforced concrete slab, this post-tension transfer floor can carry heavy loads and also can reduce cracking and deflection and allow larger column free spaces. And that's why this transfer floor system is commonly used in modern high-rise building. Next, for a background of case study, this case study is actually based on my internship project at Sarjana Plot to Shah Alam, Selangor. During my internship at BBR Construction Shah Alam, I had the opportunity to learn about the new knowledge, which is about the construction of post-tension transfer floor slab used in this project. The development consists of 4 residential apartment blocks with a total of 336 residential units. The transfer floor slab at level 9 use the BBR bonded post-tensioning system to improve the structural efficiency and create larger open spaces. And what is the objective of this case study? The objective of this case study are to study the application of this post-tensioning system and to understand the construction techniques, how the construction techniques of post-tensioning system, and to identify what is the machinery used, the specifications, and also the challenges involved during the operation of post-tensioning transfer floor. Next, for the construction techniques, first, this project uses a post-tensioning system that I just explained in the slide before. It used the post-tensioning system because the transfer flow slab needs to support heavy loads. High-strength steel tendons are installed inside ducts and it will be stressed after the concrete reaches the required strength. What is steel tendons and what is duct? Steel tendons and ducts is actually one of the equipment used in the post-tensioning system. We can watch it later at the machinery and equipment section. So next, the installation of tendons. The tendons are installed according to the PT layout drawing, the post-tension layout drawing, the structural drawing that prepared by the engineer. Then, strong formwork is installed to support the heavy transfer slab during concreting. And finally, the top and bottom reinforcement bars are placed and coordinated with the post-tension tendons to avoid any clash. And after all the reinforcement and tendons are complete, the concrete is finally being poured. The concrete pumped continuously, and also the concrete is compacted and cured until it reaches the required strength. And next, the stressing process, which is the tendons are then stressed using hydraulic jets, and the illumination is checked to ensure it meets the design requirements. It must follow the structural drawings. And finally, for the formwork installation, the cement grout is injected into the ducts to protect the tendons from corrosion, and also to improve the bond between the tendons and the concrete. So that's all for the construction techniques.
Assalamualaikum warahmatullahi wabarakatuh. My name is Natika binti Muhammad Syafi'i. Today I want to present about method of construction. First, we have a concrete grid. High strength reinforced concrete is used. Stressing start only after required cube strength is achieved. Cube test verify concrete strength before stressing. Slab thickness for the number 2. Transfer slab is thicker than normal slabs, designed to carry heavy loads and reduce deflection. Thickness depends on structural design requirements. For the number 3, we have a PT tendon specification. Uses low relaxation 7 for wire steel strands. Installed in galvanized steel ducts. Tendons are stressed and grouted for strain and corrosion protection. So we move to the method of construction for the sequence step to installation. First, we have a fabrication and preparation of PT materials. Prepare post tensioning is a PT material. Cut strength to required lengths. Install dead end anchorage. Inspect all components before installation. For the number 2, we have an installation of formwork and staging. Install soffit and side formwork. Provide temporary support for the slab. Mark tendon opening. Check alignment and stability. For the number 3, we have installation of bottom reinforcement. We must to install bottom reinforcement bars. Add extra reinforcement where required for to use. Ensure proper reinforcement placement. For the number 4, we have installation of PT materials. We have to place that according to shop drawings. Insert pressing strands. Install anchorage and grout vents. Seal duct joints to prevent concrete leaking. For the number 5, we have to installation of top reinforcement. Install a top reinforcement above tendons. Add a perching shear for reinforcement around columns. Follow structural drawings. Number 6, we must do inspection and checking of tendon profiles. We have to inspect tendon position, verify with approved shop drawings, adjust any incorrect tendons alignment. We move to the method of construction. For the number 7 is concrete casting. Pour concrete into the formwork and compare concrete using vibrators. And then we must to cure until a required strength is achieved. For the number 8, we have a stressing of tendons. Remove anchorage formwork. Stress tendon using hydraulic jet. Check tendon elongation, giant design values. For the number 9 is sealing of anchorage resist. Seal anchorage resist with mortar. Prevent grout leaking and protect anchorage. For the second last method of construction. Number 10, grouting of tendons. Inject cement grout into ducts. Fill all voids completely. protect tendons against corrosion. For the last one is patching and finishing work with repair surface. Perform final inspection and complete the transverse flap. Okay, we move to the another slide is specification applied. We have a 8 specification applied. For the number one is a processing system, bonded force tensioning system, increase strength and reduce cracking. For the number two, processing strength and specification, low relaxation 7, wire steel strength, mill certificate required for quality assurance. For the number three, ducting specification, galvanized steel duct protect tendons, joints sealed to prevent grout leakage. For the number four, we have a tendon profile specification. It was installed according to shop drawings that it was maintained for 10 millimeters tolerance. For the number five, we have a stressing specification. It was stressed after concrete reached required strength. Check tendon elongation during stressing. For the number six, encourage specification. Use lift end and dead end encourage. Reaches seal after stressing. For the number seven, grout specification. Cement grout fills tendon ducts, protect tendons from corrosion. And the last one is quality control specification. Inspect materials and tendon profiles, calibrate equipment, and verify test records. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kabidis. Good day everyone. Today I will present the machinery and equipment used in the construction of the transfer flow system for this high-rise building project. The project use a combine of construction material, heavy machine and special equipment to ensure efficient and such quality. High strength concrete and self-compacted are used to provide excellent strength and durability. For the post tension system, important component include the duct, steel, tendons, grout or hydraulic stretch equipment to apply the requirement presentation force. Heavy machine include the excavator, bulldozer, mobile cranes, tower crane and passenger hoist are used excavation, lift material and transportation workers safety to higher floor. In addition, surveying equipment ensure accurate measurements, while scaffolding and safety system provide a safe working environment. In conclusion, the proper selection and use the machinery and equipment are essential to ensure the project is completely safety, efficient and according to requirement quality standard. Thank you.
Hello, my name is Naima Sarimita Mamainwa, and today I'm going to show you what the problem and the solution of this project. So the first problem consists in the project it is tendon congestion. What is tendon congestion? Tendon congestion is our many processing tendons placed in a limited area that can cause difficulties during the reinforcement installation and concrete pouring. It also might affect the concrete floor and can reduce the construction quality. So the solution is need to be coordinated using IBM and shop drawing to proper ensure the arrangement and spacing of the tendons, the reinforcement, and the other structural element.
to before construction began. It is helped to prevent the clash and to improve installation efficiency. The next problem is concrete cracking. Concrete cracking occur when, due to shrinkage, temperature change, improper concreting mixing, or insufficient curing. This can reduce the durability and strength of the structure. And the solution is apply a proper curing method such as water curing compound, and maintaining suitable moisture to prevent the condition to be shrinkage and improve concrete strength development. The third problem is safety issue during work at height. Workers face risks such as falling objects, and accidents when carrying out the construction activity at high level. The solution is implement a proper safety measure including safety nets, lifeline, guardrail, personal protective equipment (PPE), and a regular safety inspection to reduce accident and protect the worker.
For the next slide, I will be presenting about the key design requirements for this high-rise building. So they are focused on three main aspects. The first one is structural stability. The post-tension transfer floor actually plays an important role in transferring loads from the upper floors to the supporting structure below. And it also helps reduce cracking and deflection that makes the building stronger and more stable. The second key design requirement is wind resistance. Since this is a 13-story building, the structure must be able to withstand lateral wind loads and safely transfer this force to the foundation. Lastly, efficient vertical transportation is essential. The building is equipped with lift and staircases to ensure smooth, safe, and convenient movement for residents between all floors. That's all for the key design requirements for high-rise building.
In this slide, I'm going to present about main construction stages. Okay, first stages is residential design. What is residential design? Is a creating custom home to tailor to individual lifestyle needed. Second, a commercial spaces. Commercial spaces designing office that enhance the productivity and employee well-being. Third is landscaping planning. It is an integrating outdoor areas with a modern architectural structures simultaneously. Okay, this slide is about conclusion. So the conclusion is this: post-tension transfer floor slab are efficient structural system for high-rise building, and it is providing an excellent load transfer, like greater structural strength, and reduce deflection and cracking. And it is also to improve design flexibility. The Saujana plot 2 case study demonstrates that the BBR bonded post-tensioning system enhanced the structural performance when supported by a proper labor and specialized equipment. Although the system requires careful planning and a technical expertise, it is a remain a reliable and durable solution for a high-rise residential building development. That's it for our presentation. Thank you very much.